Let's go through very quickly. Okay, we did this last week, right? Okay, the next lesson, I'll give you the graph on the cooling curve with notes here as well. Then, of course, the entire summary of the whole chapter. So if you look at this graph, okay, for the new students, okay, this is a very good graph for you. Why? It's going to follow you all the way until O levels. Okay, so if you were to look, very useful information will be like, okay, this is where you have the melting point and then the boiling point. As you start heating a solid, its temperature will rise up to a certain point, right? Where it starts to melt. Okay, this is known as melting. During the melting process, part of the solid, will start to convert to liquid state and temperature remain constant. Common question will be, why is it that temperature remain constant? So this is where we have our answer. Okay, just to quickly tell the new students what we have here. After melting is completed at point C, as heat is continued to be supplied to the substance, okay, the liquid will gain in temperature, all right, because it's taken in the heat energy. So up to a certain point, at D, it starts to boil. And that's when you have liquid and gas state together. Why does temperature remain constant? The answer is that also. Okay, so this is the graph. Then we also went through the summary. This was done last week as well. Particle arrangement in solids look like this: liquids and gas. Okay, so these are the various character traits or characteristics of solid, liquid, and gas. Okay, forces of attraction between the particles in solid, very strong, liquid strong, and then gas is very weak. How are they arranged? Very closely packed in fixed position. For liquid, they are close, and then gases far apart. So this fixed shape and fixed volume, you learn this in primary school. All right. Compressibility, you learn in primary school as well. This last row here tells you how particles move in solid, liquid, and gas. So for the solid particles, they only vibrate in fixed position. Liquid particles can slide over one another throughout the liquid, and gas particles move at extremely high speed. Okay. So look at question 1. Question 1 asks you this question about the curve. Yeah. And then this is the heating curve. So things I'll take note when I'm reading a question will be heating curve of a substance. Okay. And then solid state, liquid state, and gas state all stated for you. So they're trying to ask, okay, which of the following shows the correct melting point and boiling point of the substance? Yeah. And then the horizontal line shows the change of state. If you can read off the graph, right, this is the value. Okay, so this is where you have the boiling point, and this is where you have the melting point. Therefore, answer is A. This is not difficult. Okay, this is not difficult because quite simply, they want you to be able to read off the graph. But we have students making errors here also, no? Don't be surprised, because they forgot that during melting or boiling, temperature remain constant. So when you want to identify melting point or boiling point, always look for horizontal line in the graph. Tamaya, you familiar with this? Yeah? Okay, good. Question 2, the following shows cooling curve of a substance. So now this is the opposite, and this graph I'll be giving to you next week with the detailed explanation. Right, so if you can see, all right, there's an A, B stage here, and then B, C, C, D, D, E, E, F. I'm going to get someone to tell me what are the various states present in each range. Okay, Dina, can you tell me for A, B? this range here, AB, what is the state of this substance? So from A to B, what's the state? Dina? Is it solid state? You type in solid state. What do you think? So Dina, if I have solid state here, Dina, turn on the camera, Dina. So if this is solid state, what happens during cooling? Do you understand the meaning of cooling? Temperature is decreasing, right? So if a solid is here, if let's say this is the solid state, and I cool it further, can you tell me what is the change in state here? What will solid change to when it's being cooled? Change to liquid. So you mean over here, this is solid plus liquid. Do you think so? Dina, tell me, what is this process when solid changes to liquid? Melting. During melting, do you think temperature is taken in or given out? Taken in. So if that energy is being taken in, how come the temperature is decreasing? Freezing? Do you think this is freezing? If this is freezing, then it should be liquid changed to solid, right, Dina? Yes or no? Yeah, but you're not telling me the correct info here. You're telling me this is solid state. And upon cooling, the solid changes to a liquid. Is that possible? That's not possible. Would you like to change your answer now? Okay, so try again. What is the state of the substance at AB? Yes, Bernie, you can go. A gas. Okay, so now you think that it's a gas. So let's try. If this is a gas at this part of the curve, is a gas state. Upon cooling, what happens? What is this horizontal line representing? It represents decreasing. The temperature decreases here. So the gas becomes cooler, correct? So the gas becomes cooler, all right? It will come to a point, okay, where it's moving very slow. The particles are moving very slow, come closer together. What happens there? Remember in primary school, you learn, right? When a gas hits a cool surface, it loses heat energy. What is that process known as? Yes, this is condensation. So what are the states over here for B to C? All right. So while condensing, right, we will have gaseous state and liquid state existing together. So this point is where condensation has completed. So what is CD? Okay, so this whole stage here, all right, what will be the state of the substance in the whole range over here? Charmaine? Charmaine, what is this state? Oh, can't hear you. I think your mic is not so clear. Okay. Can you all hear her? No, right? Maybe you want to type in, let's say your mic is not working. I think your camera is faulty. Now your mic is also failing. Maybe you want to check on it, Charmaine? Here, from C to D. Okay, I'm waiting for the answer here. No, actually, this is not the place where melting took place. From C to D, if you see that the temperature is decreasing, it cannot be that the substance is melting. Okay. Now, I really have to call upon all of you. I'm going to call your parents up and have your cameras turned on. Okay, it seems like you are not focusing. A few of you. I can't be going through. I mean, I can if I choose to just be the one explaining, telling you the answer, but you're not participating. When I'm asking you questions, it seems like you can't answer. I don't think that is the outcome you all want from tutorial, right? Yeah, you sign up for tutorial to learn something. So if you're not learning, then I have to ensure that learning takes place. So now it's like giving me some information that a couple of you really not focusing, no? Okay. Yeah, I know. Yeah. I saw your answer with you. Charmaine, look at it again. Were you listening when Dina was actually telling me the answer? Dina got it wrong at first. I pushed. I didn't let her go. And that's for a good reason. I hope you all understand. Okay. This is not going to be a kind of tuition where you just come in. If you like it, you don't like it, you don't come in. And then when you're in, you can choose to do your own thing. You're just signing your attendance. I don't think that is the thing your parent wants for you also. For me, it's a very clear-cut thing. You come here, you have to learn. I have to ensure you learn. I'm a parent too. So I have to explain to you why I am insisting that you guys must surface it if you don't understand. You get what I mean? Yeah. If I'm just after the money, I don't have to bother, right? I just make you all happy. You'll just sign on, keep paying for it. But your mom and your dad work so hard.